Okay, good morning, ladies and gentlemen. So we're, again, almost done with summer school. I think we actually only have 2 lessons left. So today we're doing lesson 6, which is real world expressions. And then next week, we're going to finish up with the final lesson, which is real world equations. So like usual, kind of same format as always, we're going to start off today with me just going over the first, half of the lesson. I think it's about the first 10 slides. Then you guys are going to finish the rest of the slides on your own. And then Monday, it'll just be a quick review, and we'll probably put some kind of game together on Monday. All right. So we're looking at real world expressions. It's day 1, so let's just start with the objective for today, right? So the objective, it says, in this lesson, you will use variables to represent numbers when solving real world and mathematical problems, right? So basically, it's just going to give us a couple of scenarios, and it's going to kind of walk us through how we take a scenario that's written out in words and express it as a written word problem, right? I'm just going to set the chat to host only right now so that we can try to focus on the lesson. And let's get started, right? So it's giving us a scenario to think about first, and then we're going to talk about later on how we can relate this scenario to using variables. So it says here that Horatio runs a machine company that makes parts for airplanes. Lately, he's been receiving a lot of orders, and he's not sure whether he can complete all of them. He decides to estimate the time it will take to complete each order beforehand. It takes 2 minutes to manufacture each part. So we got some numbers. And it takes 10 minutes to pick up all the parts for an order, right? So basically, you think about it, he'd have to walk to somewhere, he'd have to collect all the parts together, that takes 10 minutes, and then putting all the parts together takes 2 minutes for each part, right? So if he had to, say he had to make 20 different parts, it's gonna take him 10 minutes to get all the materials for those parts, and then 2 minutes each to make those 20 parts, right? So just to kind of give you an idea. It says, but the number of parts in each order varies depending on the client's requirements. So the time taken for each order is also going to vary, right? If he's making less parts, it's going to be faster than if he's making more parts. So we have some variability there, right? So that's why we would include a variable to represent how many parts he's making. So it says, if he's able to make an expression, that's going to tell him how long it's going to take to make and also pack the parts for an order, right? So actually I got that order in reverse. So it seems like he makes the stuff first, and then it's 10 minutes to pack it all up, right? So he made a bunch of parts, and he has to pack them up into boxes to ship them out, all right? And you're probably gonna end up actually working with this part later once you get to that activity on slide 11, I believe it is, all right? But again, that's an example of when we use an expression in math. And I know I went over it at the beginning of the unit, but just try to remember the difference between an expression and an equation, right? Both of them have variables, but the difference between an expression and an equation is that an equation has an equal sign, right? An expression does not have an equal sign. That's literally the only difference, right? So it says over here, when you're writing an expression to represent a situation, we use certain keywords to identify the mathematical operations in the expression, right? So these are some key things that you guys are gonna have to just kind of remember as you're going along. And a lot of it, sometimes you can just kind of pick up, right? So if we're talking about addition, we might see something like, sum, we might see add. There are different words that mean you're talking about addition. If we're talking about subtraction, again, there's another group of words. You might see, minus. Another big one that we see that talks about subtraction is difference. Difference means subtraction, right? There's a whole list of words. I forgot to look one up ahead of time, but I'll give one to you guys next week that kind of shows you what all of the different symbols mean, right? If we're talking about multiplication, usually you will see things like times. That's the biggest one that tells you we're multiplying, or it might just say multiply. Sometimes you have to read the question to figure out what clues are telling you that you're talking about addition, subtraction, multiplication, or division. And again, I'm sure that you guys have seen a list like this in the past, and I'll just find one a little bit later to show to you guys as well, okay? So over here, it says, for example, the keywords times and sum in 2 times the sum of X and 5, right? So we also had some practice working with expressions like this at the beginning of our unit. So we would say 2 times, right? So that's 2 multiplied by, and this is also where you need to be careful because you might make a mistake and say 2 times the sum of X plus 5. This expression here is not the same as this expression. So when it says the sum of X and 5, right? What I'm thinking is that we need to add together X and 5 first. Can you clean your table, please? And then we need to multiply that by 2, right? It might also say double or twice. So it will always say times or multiply. Sometimes, you know, we have words like tripled, quadrupled, quintupled to mean different multiples. All right, so we're going to look at a couple of examples on the next few slides, and I'm just going to try to explain those examples and just make sure that you guys understand where these expressions are coming from, right? So over here it says, Fred has a collection of 25 rear sport cards, right? So he has 25 cards. It said his dad buys a set of sports cards for Fred's collection. So we don't know how many cards are in this set of sports cards, right? There could be 10 cards in that set, there could be 20 cards, there could be 30 cards. We're not exactly sure of how many cards there are, right? So what we do in math is we say, okay, I don't know what this value is, so we let a variable represent that. So we say, okay, so let's let M represent how many sports cards his dad got. So if we want to figure out how many sports cards that he actually has, we just say, okay, so he started out with 25 sport cards. His dad bought him M more, right? Remember, M represents a number. And this here is just that basic expression that represents how many he now has, right? And then once he opens up the box, he can say, okay, I just open up the box and I can see that in fact, you know, let's say there were 10 sports cards in here. So once he knows how many sports cards are there, then he can say, okay, so because I know that's 10, I had 25, so 25 plus 10 means I have 35. But until we have that piece of information, I can't do anything else. This is just the expression, right? It's kind of a placeholder until you kind of determine how big that variable is, and then you can do something with it. So we've got another simple one down here. We're saying that Chloe is eating a few slices from a pizza that's cut into 8 slices, right? So imagine a standard pizza. It's cut into 8 slices. That's a pretty bad pizza shop. I would not recommend you go there if that's how they cut it. So we're trying to write an expression to represent how many pizza slices are left, right? So you also got to be careful. Left means how many remain, right? So we started with 8 slices. We're saying that Chloe, again, she ate a few, right? We don't know what a few slices is. So again, that's something I don't know. We represent that with a variable. So what they chose here is they said that they're going to represent the letter P to be how many slices she ate. So if we started with 8 slices and she ate P of them, I would subtract to figure out how many pizzas are left, right? And if this is confusing, just think about a quick example, right? Let's say, for example, she ate 3 slices. So this is my very bad pizza. She ate 3 of these. I just got to redraw this, sorry guys. Probably not going to be much better, but there we go. Sure. She ate 1, she ate 2, she ate 3 slices. So the amount left is going to be 1, 2, 3, 4, 5 slices, or just 8 minus 3, right? We started with 8, we took away 3. So these expressions on this first page here, just please let me know if you have any questions here. These should feel pretty simple, right? And again, just remember that they're just representing information that we don't actually have yet. It's kind of like a placeholder. That's how you think about a variable. All right, so we've got another couple of expressions on the next few pages. This one's going to involve division. So we just need to be a little bit careful because this is where students usually make some mistakes. It says that Caden and his friends go out for dinner at a local restaurant. So this must be pre-COVID because they are eating inside. There's no social distancing, no face masks, all right? This restaurant's about to get a violation. Now it'll be too loud. So they decide to split the bill equally among the four of them, right? So this is the key information, right? Caden then volunteers to pay a tip of $15. In addition, so there's a lot of things going on here, to his share of the bill. So the expression that we're gonna write is for the amount that only Caden is gonna pay, right? So I don't know, let's say this guy right here is Caden. So sometimes it helps to just pick an example. I don't think it's too loud. Pick an example to use, right? So let's say this is the restaurant. I'm gonna pick an easy number, right? Let's say, okay, so let's say that the bill for all the food together came out to $100, right? So first, let me try to figure out how much he's gonna have to pay, and then I can try to simplify that and use a variable, right? So if the bill cost $100 based on what it says here, it says first that they're gonna decide to split the bill equally among the four of them. So I have four people for $100, so I know that each person I would divide is gonna have to pay $25, right? Now it says that on top of that, Caden volunteers to pay a tip of $15. So this tip is not split amongst everybody. This is only what Caden is paying, right? So Caden is in fact gonna pay the $25 plus the $15 tip. He's gonna end up paying $40, right? That's how much he pays. But the check doesn't actually cost $100, right? We don't know how much the check costs. So we use a variable. We say, okay, so this check doesn't cost $100, it costs X dollars. Because again, I don't know what it is. I don't know if they just, went in and they got some hard-boiled eggs or if they ordered some Maine lobsters and steak. So it could be very cheap, it could be very expensive. Whatever that value is, we're gonna let the letter X represent that. So then I say, okay, look at this example that I just did. It's basically gonna be the same thing. So first, to figure out how much Caden spent, I'm gonna take the total cost of the bill, divide that by 4, right? So this here, this is like what I did over here, 100 divided by 4. So this represents his share of the bill. And then, right, remember, he also adds on that $15 tip, right? And $15 might sound like a big tip, but we don't know how much they spent, right? If they spent $10 at the restaurant, this is a really big tip. If they spent, $500 at the restaurant, this would actually be a pretty crappy tip, right? But either way, this here now is gonna tell us how much just Caden has to pay, right? If they asked us for how much how much everybody is paying all together, that would be a different expression, right? That would just simply look like, okay, so altogether it costs X dollars plus $15. So altogether, this here is how much everybody is paying. This here is how much just Caden is gonna pay. So we need to be really careful when we're writing these expressions to make sure that we're answering the question. So it's always good practice to go back and see, okay, so let's write an expression for the amount Caden will pay. Okay, so then I say, okay, so does this represent how much he's gonna pay? Yes, right? So pretty much always look at the very last sentence of a question to try to make sure that you correctly answered the question and that you didn't answer a different question, because that is a very common mistake in that. Okay, so now we've got an example here, so we can try to do ourselves. I'll read it out loud. It's set to host only. Take a minute and give me your answers here. We're not going to do Kahoot today. We'll probably do Kahoot on Monday to practice this stuff. All right, we're usually going to do Kahoot on the second days of the lesson. So I'm going to give you guys 2 minutes. When you get the answer, write it in the chat here. Let me just read it out loud. It says, Fred paid $52 for X gallons of gas. If each gallon of gas costs the same, what is the expression for the cost of 1 gallon of gas? Again, it might help to think about a example here, but write down in the chat what you think the answer is. I see a couple of people giving me answers. AJ, you got it correct. Jinghao, correct. Jaden, you got it. Alfie, you got it. Yep, good. Sissy, you got it. All right, about another 30 seconds. Anybody that's still working on it?
Hello.
Hey, good morning.
Hello.
Evan, I think. Michael, try again.
Yes.
All right, about 10 seconds left. Just get your answers in. I'm seeing the majority of people getting it right, which I'm happy about. Okay, so actually, does anybody want to volunteer to like unmute and just speak and say, explain why the answer is the answer? Or I can also, I'll just shut the chat to public in case anybody also wants to type it to the room instead of out loud. All right. Okay, so it's the third one. Can you explain why, Alfie, or anybody else? So I got most people got it correct and said that the answer is going to end up over here being 52 over x. How do we know that's the correct one? Because it's not telling us to divide here. So how do we know that we have to divide? Does anybody think that they can explain that? Okay, so we know it's division, right? So a good way to do this is to kind of think about an example, right? So give a number, right? Let's say, so say for example, X was 10, right? That would mean that they purchased 10 gallons of gas, and then you can try these numbers out and see if any of them make sense, right? That's something that you can always do when you have a variable like this. So let's say you tried this one. You said, okay, so 52 minus 10, that gives me 42. And I would say, okay, does it make sense that my gallon of gas costs $42? I'd say no way, because I bought 10 gallons. That doesn't work. If I tried this one here, we'd say, okay, so does this work? 52 times 10. So does it make sense that my gallon of gas costs $520? No way, right? So the only one that makes sense is this one here. Again, this one here gives you $62 for a gallon of gas, which again makes 0 cents. So again, if we do this, we'd say, okay, so 52 divided by X. This here would mean that a gallon of gas is $5.20. So this is the first one that kind of makes sense. Like, okay, so that is a smaller number. This probably makes more sense than all of these others here. And then you would just check it, right? And say, okay, so if I'm buying 10 gallons of gas and they cost $5.20 each, I just need to multiply to find this, right? And again, right, Alfie, it's like when we found the unit price, exactly, like how you're bringing that back to what we did earlier, this unit, right? Remember we talked about, you know, making purchases, depending on how many you bought, you divide the cost by how much stuff you bought to figure out how much it costs for just one of those things, all right? So exactly, this here is a unit price because it's the cost for 1 gallon of gas, all right? So I'm glad that most people got that there. All right, we've got a couple of slides left. Sorry, Penelope, please sit down. We've got a couple of examples left here, okay? So we're looking now over here on this slide. It's gonna actually explain how you can have 2 different expressions to talk about the same problem. And it's gonna sound confusing at first, but let's just be careful here, okay? So it says sometimes you can write different expressions for the same word problem based on the different meanings assigned to the variable. So this hinges on what you name your variable, okay? So we're talking about two people here. We're talking about Heather and then her daughter, Lauren. So this here is Heather. This here is Lauren. Right? So right now they are peeling a bunch of carrots. I don't know why, maybe they're making carrot cake, maybe they got a bunch of rabbits, who knows? But this is what they're doing, okay? So it says that in this case, two quantities are unknown, the number of carrots peeled by Heather and the number of carrots peeled by Lauren, right? So we don't know how fast they're peeling. The only piece of information that we actually know here is that Heather can peel 2 more carrots in 1 minute than her daughter, right? So if Heather can peel 5 carrots, that means that her daughter could peel 3 carrots. If we know that Lauren could peel 10 carrots, that means that her mom can peel 12 carrots. So mom is gonna peel 2 more than Heather, right? So over here, now we have to be careful, right? If we're trying to write an expression to figure out how many carrots they can peel, it depends on what X represents. So this first example here, they're saying, okay, so what if here, if X represents how many carrots Lauren can peel? And that's a weird way to spell Lauren. I didn't spell it like that. So X represents how many carrots Lauren can peel, right? So if Lauren is able to peel X carrots, okay, I know that she can peel X carrots. Her mom can peel 2 more than her. So her mom can peel X plus 2 carrots. So all together, if I want to see how many they can peel, we just add those together, all right? So X plus 2, we have 2 X's together. That gives us the expression 2X plus 2, right? Again, that's if I let X represent how many carrots Lauren can peel. But you actually end up with a different expression if instead of that, you say, let's let X represent how many carrots mom can peel. So if we're giving it a different meaning and now we're saying that X actually represents how many carrots her mom can peel, I know that if her mom can peel X carrots, mom peels 2 more, right? So that means that I actually would have to subtract 2 carrots here. So she peels X carrots, she peels 2 less. So I end up with a different expression, right? That previous expression ended up being 2X plus 2, but now the expression that I have over here is actually 2X minus 2. But again, they are actually both correct as long as we define those variables in the right order, right? So a lot of times on tests, they tell you what variable means what. So they would tell you, you know, okay, so X represents how many Lauren peels, or X represents how many Heather peels. If they don't, right, you need to define the thing. So when you start getting into higher level math classes, not so much in 6th or 7th grade, you would need to write something down like this. You would say, okay, so technically I'd say, okay, so let X represent the number of carrots and in this example here, I would say peeled by Heather. Excuse my poor penmanship, right? So again, once you start getting to, you know, algebra, high level math classes, and you're writing out a problem, you pretty much always are gonna start by defining your variables. So you have a statement like this, that lets you know then, okay, so does X represent this one or does it represent that one? It gets rid of the ambiguity so that people can actually figure out what your expression means, okay? So I am seeing that we're starting to get a little bit more distracted in the comments there, so I'm just gonna shut them off for a second. And we've got a couple more slides to go, guys, all right? I think only 2 more, so just stick with it. Now, over here, we're gonna look at an example that involves sheep, all right? So it says, one way we create expressions is by starting with a formula using words. Consider this example. Andrew wants to build a rectangular holding pen for his sheep, right? So hopefully this is relatable. I'm sure you guys all have sheep farms out there, right? So it's talking about a rectangle. it's probably going to help to draw a rectangle. So let's draw a rectangle. I know you guys are impressed by my drawing skills. Here's my rectangle, right? It says, he notes that the length of the rectangle should be twice as long as the width. So this is the length here. He's saying that the length needs to be twice as long as the width. So let me just write here, right? This is my width. This is my length. So let's think about an example, right? What kind of rectangle that will work for Andrew, right? I could have one that's like, you know, the length is 10. The width could be 5. That works. I could have a different rectangle where, say, you know, the length is equal to 30. The width has to equal to 15. It's going to be half of it. Or I could say, you know, okay, so let's say I know the width. The width is 10. The length is double it, so I double that, 20. So if I know the width, I know the length has to be twice that, right? So it's really sufficient to just say, okay, this is my rectangle, and because of that constraint, all I need to give you is the side of how long the width is, and he's going to be able to figure out what the length is, right? So we say, because this can change, instead of calling it 10, let's call the width A here, right? So if the width of the rectangle is A, the length of the rectangle is 2A. I'm just doubling it. It's 2 A's, right? But now we have to finish reading this to figure out what he actually wants to do, right? So it says that he wants to put a fence around the pen, right? Probably so that the foxes don't get in to try and eat the sheep, right? So he needs to try to calculate its perimeter, right? And this is mathematical terminology. I actually believe we talked about it at the beginning of the course. Remember, perimeter is basically just the length around the outside of a two-dimensional object. So if I was to walk around this rectangle, right, that's going to give me the perimeter. The way that I find that is actually pretty simple. We just add up all the side lengths. Or they have a formula for you here, which basically gives you the same thing. So the way that you can find perimeter is you just add together your two sides, and then you double it. Or also you could just add all four side lengths together, right? So what they're saying here is they use that formula. So if it's 2 times the length plus the width, it's 2 times, we said the length, remember, was 2A, plus the width was A, and then they just simplified. So inside the parentheses, I have combined terms, combining like terms. If I have 2 A's, I add 1 more A. Altogether, I have 3 A's. And then in the front, I just multiply 2 times 3 A's, means that I have 6 A's altogether, right? So remember, in this case here, A represented the width of the rectangle. That gave us this expression here, 6A. But just like that last slide where we had 2 different expressions, we can also have 2 different expressions here. So the next slide kind of goes through that, right? On the next slide, we see here that at the top, right, this is what we did on that last page to get 6A. But what you can also do is you can say, let the length be A, and the width is going to be half of that, right? So if, right, and just think about examples if we're getting a little confused here. If the length was, say, 40, the width we know is half of 40. That's what this means. That means take my width, divide it by 2, so my width would be 20. And in this example here, works out a little bit different. So this is the math they did over here, and we might get a little bit confused with the fractions, but they're not too hard, right? Let me show you over here. So it's 2 times the length, which we said is A, plus A divided by 2 is the width, right? And if you were doing this yourself, 9 times out of 10, you're gonna do this one over here, because it does not involve fractions. Fractions are usually where students get confused, right? So if you can avoid them, right? But mathematically, they actually both work. So in this case over here, what they did from, you know, here to here is they added together A plus A over 2, right? The way that we do that is just think back to how would I add together, say, 1 plus 1/2, right? Anytime you're adding together fractions, first off, this isn't a fraction, so we turn it into a fraction by putting it over 1, right? And I don't have time to go over a whole, And LB? Too loud. I don't have time to go over a whole lesson on fractions, so I'm going to kind of just explain what I'm doing here. So first I would turn 1 into 1 over 1 plus 1/2. Then I need to find the greatest common denominator. So I need to get a denominator of 2 here. So I multiply the bottom by 2. I multiply the top by 2. 1 over 1 is equivalent to 2 over 2. So 2 over 2 plus 1 over 2 gives me 3 over 2, right? Same approach goes over here. You put a over 2, and then 2a over 2 plus a over 2 gets you to this 3a over 2, right? So we end up here with 3a over 2, all that multiplied by 2. And then basically what happens over here, a shortcut, is that if you're multiplying an integer by something with a fraction, if these numbers are the same, they basically just divide off. So I'm left with just this 3a here, right? But this here would be kind of a whole separate lesson on fractions, which I don't want to get into right now. Just realize that you do have two different expressions that mean the same thing. It just depends on how we define that variable. So if we define the variable as being, you know, the length of the rectangle, we got the more complicated one. If we said a was the width of the rectangle, we got the easier to use. All right, and I believe that takes us actually, okay, one more. So once you have an algebraic expression for a quantity, you can substitute different values. So we already talked about this part here, right? This is like saying, okay, so we had those rectangles before where we know, okay, you know, this is A, this is 2A. All the slide is saying here is that once we know how big things are, right? So I know over here that it says, let's assume that Andrew decided to put with a length of 10 meters. So if the length is 10, remember this one is the length, that means that I'd say this one is 10, this is half of that, this one here is 5. So we could use that expression and substitute to figure it out. So we would just say, you know, 3 times 5 gives me, 3 times 10, sorry, gives us a perimeter of 30. So this is just kind of explaining that substitution phase. All right. Now, that should take us to the practice slide for today. So remember, for the remainder of class today, we're going to be just spending time going through this activity slide here and then just finishing up. There's only 16 slides here. The last one's a summary, so you've got like 4 more slides to go over yourself. So then Monday, take time to just go over this, and then we'll probably also play a game of Kahoot where you're going to practice writing expressions from some scenarios. All right, so I'm going to stop the recording from here, and I'll stick around for the next about 15 minutes or so, just assist with any questions you guys have.